bring sediments and tremendous amounts of water as the fountains of the great deep burst forth, and they bring those up on the continental land areas, absolutely obliterating the world that then was. Tremendous evidence in the fossil record for catastrophism. Tremendous evidence in the fossil record for stasis, animals staying the same. Tremendous evidence in the fossil record for a lack of macroevolutionary intermediate forms. Now, that was just the introduction. All right, let's get started now. Fossil reconstructions of hominids, as they're called. The candidates that have led to the current Homo sapiens species that we have today. According to evolution, this process started to take place somewhere around 5 million years before present, where we shared a common ancestry with the apes, and then that diverged to what we have today. So anatomically, modern humans, a few 100,000 years, but going through a series of hominid changes that developed from a common ancestry with apes, not evolving from apes, but a common ancestry with apes. Apes essentially stopped evolving. Humans evolved from an ape-like ancestor to what we see today. Is that the case? Well, obviously, you know I'm going to say no. Well, first of all, when it comes to human origins, this is a most difficult area of paleontology, the evolution of man. Why? Well, first of all, because fossil remains are highly fragmentary. In many cases, you have a tooth or a part of a mandible, you know, the lower jaw. You have fragments of material. And then on top of that, sometimes the material gets mixed together. And so you don't know what you're reconstructing, whether you're being accurate or not. In many cases, you're looking at extinct organisms that you've never seen. Now, if you're an evolutionist, you're going to interpret that one way and reconstruct the fossil so that it fits your preconceived evolutionary idea. You have to think that way because you're a committed evolutionist. And creationists are just as biased. We would tend to reconstruct something based on our view that they're either man or apes and nothing in between. So I'll let you be the judge as we go through these and see which model better fits these evolutionary candidates, ending with some of the most recent finds, and we'll look and see what we think those might be. Also, some other factors. Sexual dimorphism. There's vast differences between males and females. For example, the male gorilla is at least twice, maybe more, of the size of the female gorilla. The male gorilla is far more robust, muscular, and has very robust bone structure, whereas the female much more gracile when it comes to the dichotomy between the two. So females would be more human-like in this case, males more ape-like, and that tends to be true for many of the primates, particularly the great apes. Infants or juveniles, much more human-like. They don't have the robust bony structures that male gorillas or any of the other great apes would tend to have. So if you're reconstructing fragmentary material, that means it's going to be very difficult for you to get it correct unless you have a large sample that you're dealing with. But guess what? The problem is we almost never have complete skeletons. It's not like you go down to Forest Lawn and dig up, you know, a skeleton or something. You're out there dealing with tiny little fragments of bone. And you don't even know if the pieces you have go together into one specimen. And in many cases, there's been reconstruction where they got that completely wrong and put different organisms, different species even, together in one organism. I'll show a couple of examples of that to document that case. So reconstructions based on the bias of the view of the particular paleontologist doing the reconstruction, that's a problem. And I'll give examples to show what can happen. The reconstruction can be completely wrong. You say, well, aren't these professionals? Yes, and for the most part, I have to say, most evolutionists are honest. They're not out to deceive people. They think evolution is correct. They're wrong in their beliefs, but they are serious scientists, and they try to do good science. There are exceptions, of course, and there's exceptions to that on the creation side, too. So just keep all of that in mind when we're looking at these reconstructions. Now, here is the diagnostic characteristics that we would expect to find if indeed we were looking at certain fossil candidates and trying to decide, are they a fossil ape, are they a fossil man, or are they an intermediate candidate in between the two? Humans tend to have large cranial capacity, 1,300, 1,350 cc's. Apes, much smaller than that. Even the great apes, no more than about a third of the cranial capacity, despite their huge body size. You know, male gorillas in captivity can be 400 pounds. A flattish type face, if you look at great apes, they have a prognathous type of face, similar to your dog. If you look at your dog in profile, you'll notice his snout kind of, so to speak, jets out profile, whereas human faces, look at the person next to you for a second, you'll see they have a very flat face profile. Okay? So that's characteristic of Homo sapiens. All right. And then humans have much shorter arms, whereas great apes have much longer arms because they brachiate through trees. We tend to have longer legs, so the ratio of shorter arms and longer legs versus great apes tends to be the opposite, long arms and short legs, because they tend to spend most of their time brachiating in trees, whereas, of course, I don't think too many of us do that I've seen. Anterior nasal spine, the bone structure of our nasal area tends to stick out a little bit, whereas theirs is more flat. General steep forehead. Your forehead is elongated, but it's very flat, whereas great apes have little or no forehead. And then small canines. Great apes tend to have large canines. Well, there's one exception to that. The small canines. Dracula has one of those big eye teeth, right? Okay, so that's what we're talking about, those eye teeth. Humans have very small canines. And then high rounded cranial vault. If you look at a human in profile, we have kind of a bulbous, almost like a bulb shape type skull. Low cranial vault for great apes. No diastema. That's a gap between the two teeth. If you look at your dog, if he growls at somebody, you'll notice in profile his canine teeth interlock. There's a gap in his teeth, and those canines interlock. You don't have that. Well, hopefully you don't. I could recommend a good dentist. Okay, little or no body hair, even though there's some of those European guys that have the hairy backs. But for the most part, humans are rather hairless. By comparison to the great apes, they have very thick hair that cover their entire bodies. And bipedal locomotion. It's habitual in humans. We always walk upright, or we tend to walk upright. Whereas the great apes, they can walk upright, but that's not their normal form of locomotion. It is quadrupedal, on knuckles, on all fours. And actually, chimps under short distances can outrun a human easily. So, you know, the evolutionists say, well, we stood up for utility. Well, it's a lot more utilitarian to be able to run fast on all fours than it is to stand up, like they say that humans did in order to walk bipedally. Okay, so we have a general evolutionary scenario that looks something like this. You know, Australopithecus to Homo habilis to Homo erectus to Homo neanderthalensis, Cro-Magnon, and fossil man. And I think they probably got it wrong. It should look more like that, is what I suspect. You know, just a joke, just a joke. Anyways, okay, let's start with our first candidate, Ramapithecus punjabicus. Okay, that's 3 units at the local college, if you can even pronounce that. And Ramapithecus was thought to be one of our earliest known hominids. 17 million years before present. It has had several various names. The problem with fossil hominid candidates is there's so few of them that evolutionists tend to give a new taxonomic name to every single one they find. So here it's called Ramapithecus punjabicus, but it's also called Sivapithecus, Kenyapithecus punjabicus, Shivapithecus. There's a whole number of these pithy names. It's not important that you remember what they are. I just want you to know that I know